So one more problem, a certain BJT has R equal to 2 kilo ohm, beta equal to 100 megahertz and beta equal to 5 at 20 megahertz. Determine the values of F beta, Ft, F beta and C pi. See, this pi indicates the parallel combination of both the resistance. Okay, so one common way of denoting the resistance is using R pi and C pi. So instead of writing the specific junction name, they would be giving R pi and C pi. That is also one more way of representing the resistances and capacitances in hybrid pi model. So you know Ft equal to beta into Fb, and that is beta at a particular frequency into F. So Ft is given. So Ft is going to be beta. Beta is 100 at 1 megahertz. Okay, so and it is 5 at 20 megahertz. First, we will consider this one. So 5 into 20 megahertz, you get 100 megahertz. For this corresponding Ft, I'll find F beta. F beta is Ft by beta. You get the answer as 1 megahertz. And you know the formula for F beta. F beta is 1 by 2 pi R pi into C pi. So once you know the value of R pi into C pi, R pi is 2 kilo ohm as given in the problem, and you know the value of F beta. So you can find the value of C pi, it is going to be 80 picofarad. So we have considered the value of beta at 20 megahertz and found out the value of C pi. Same way, you can repeat the same problem when consider the value of beta is 100 at 1 megahertz. If you consider that value, accordingly, the value of C pi is going to be different. Okay, so you get two values of C pi, which is at the condition when beta equal to 5 at 20 megahertz, this problem is solved. You get the value of C pi as 80 picofarad. And when the value of beta equal to 100 at 1 megahertz is considered, corresponding value of C pi you will be getting. Okay, the corresponding value of C pi is got. Okay.